Hi again, everybody. Now that you know about logarithms and how to use them, we're going to use some properties. Good news is there's only 3 properties, so there's not too much to really do to it. Logarithms are exponents, and so you use the rules of exponents. So when you're multiplying, you add. So like if we have 2 things that we're multiplying like this, m times n, I'm right here, then you would just add. Now when you do this, you do have to sort of separate this out. The log base whatever, this is log base b, goes with each piece. It's that simple, honestly. That's all you have to do. So let's take a look at some of these. We're going to use this product property, and we're either going to put it into a single logarithm or we're going to spread it out. So into a single logarithm, meaning you only write the logarithm once. You should have just the word log or the natural log just one time. And when you see add, you know you're multiplying. So you keep the log, you keep the base, and you multiply. Same thing here. This is the common log, no base, and we're going to multiply. Now you should continue to multiply and finish the problem. Here we're going to multiply, so we have the natural log of 4x squared times 3x to the third. And so that'll give us the natural log of 12x to the fifth. Well, multiplying means add your powers, of course. Now, for 72, there's kind of a lot of ways to get to 72, so pick 2 numbers and only 2 numbers. You multiply, you get 72. I'm going to pick 8 times 9. So that's kind of random, and it has lots of right answers. Now, to do this one is a division problem, and to do this one with addition is not as easy. We'll do it here as a division problem in a second. But if we think about 9/10, this is 4/10 plus 5/10. This would be then, of course, we could reduce this. This would be the natural log. 4/10 reduces to 2/5, and then the natural log of 1/2. That one, I don't know that I would do that as a product property once we learn the other properties. Now for this one, you do have to factor, and you will have some factoring, of course, because that never goes away. So that's how you factor that one. So this is going to be the log base 5 of x plus 2 plus the log base 5 of x minus 2. So that's the product property. Quotient property says if you're dividing, you subtract, which that's just the exponent property, but it's also the logarithm property. So if we have the log base b of m, we're going to subtract top minus bottom, minus log base b of n. So when you're subtracting, you're really dividing. So this is really the natural log of 96 over 6. Of course, that reduces, so please make sure you finish the problem. That's the natural log of 16. Sorry, I got a little crazy. So for this one, we're going to have the common log, just the log, and then this 8x to the 10th will be on top, and 4x squared on the bottom. So let's reduce this to, and of course you subtract the powers, x to the 8th. Radicals, this is log base 7 of the square root of 40 over 5, which is really the square root of 8, and 8 breaks down to 2 radical 2. So this is the log base 7 of 2 radical 2. So with your giant radical, you can divide. You don't have to try to simplify first. Divide first. It's a little easier. Now again, here's a problem 8. We got to come up with 2 numbers that divide to get 8. I'm going to go with 16 over 2. So this is log base 3 of 16 minus log base 3 of 2. So this is the one that we did up here. It's much easier, this version. Natural log of 3 minus natural log of 4. And we could have done that with number 5 as well, but they wanted us to add, so that's how we did it. This one's going to be the log of x minus 7 minus the log of x plus 1. We don't have a property for adding and subtracting, so adding and subtracting stay adding and subtracting. So don't try to overdo it or do too much. Power, if you have a power, you just basically bring it out in front, turns it into multiply. So this is n, not the log of n, just a plain old n times the log base 6 of m. Oh, log base b, sorry. So this is just going to be, we put this back on here, the log of 6 to the third, and 6 to the third is 216. Here we have 1/2 back on there, log base 4 of 81 to the 1/2. Now you can type that in your calculator, but 1/2 is power over root. This is important to know. 1/2 is the square root. So this is really just the log of 9. In number 15, our power is this whole thing. So the natural log of 4 to the x minus 1. Now to undo it, we just bring it down. So this is going to be x times the log base 2 of 5. So 1/3 is your power here. So remember, the square root is the 1/2 power. Cube root is the 1/3 power. You do have to know that here. Otherwise, you won't be able to make it the right power. So we have the natural log of 2x plus 1 to the 1/3. We'll bring this out. So 1/3 times the natural log of 2x plus 1. 64 has to be rewritten with a power. That's the whole point of this. This is 1 over 8 squared. And then to bring this up out of the bottom, this is really 8 to the negative second. So our power is -2, log base 6 of 8. All right, so here we go. We're going to mix all the ideas together. These problems are just a little bit more than the ones on the front. Those are all like one-step problems. So you've got to take a look at all the things that you have. We have, looks like a power. So it looks like we're going to have 9 squared. And we're also going to have 2 to the third. You can put that in the calculator. That's 81 times 8. So we're going to have the log base 4 of 9 squared times 2 to the third, and then you have to multiply that out. So this is the log base 4 of 648. I see some traction, also a power here, so this is going to be like this. So we have the log of 80 over 4 squared. So 80 over 16 is a 5, or just put it in the calculator, I guess. I don't know why I keep doing it without it. The log of 5 is the answer. Now for this one, you have the third. We have pq to the third, and we have pq squared to the fourth. That's a lot of p's and q's, so we got to make sure we do the power to the power. So we're going to have the natural log of p to the third, q to the third, p to the fourth, and q to the eighth. And then, of course, we add the powers together. So we get the natural log of p to the seventh, q to the 11th. 1/2, remember 1/2 is the square root. So let's take a look at this. This is a lot. We're going to multiply these together. So we have the log base 5 of x to the 6th times x to the third, and then all of this is to the 1/2 power. So we do 6 to the 1/2, that's x to the third. And then we do 3 to the 1/2, that's 3/2. And then you have to add 3 and 3/2 together. That's going to give you 9/2. Remember, that's power over root. So this is log base 5 of x to the 9th, second root or square root. For this one, we put the 2/3 back on the 64. So we have 64 to the 2/3. You can put that in your calculator very easily. The calculator does the exponents with the fractions very well. And then we have 8 squared. So we have the natural log of 64 to the 2/3 on top of 8 squared. So this is 16 over, it's 16 over 64. So this is the natural log of 1/4. Negative exponents make fractions. Negative exponents do not make negative numbers. So we have log of 15, and then we have 1/9, which we're multiplying, and that 1/9 is raised to the 1/2 power. Actually, the whole thing is raised to the 1/2 power. All right, so let's take a look at this. So we have 15 times 1/3. I'm going to multiply these together. we get 15/9. And then we got to take the square root of that. So we get radical 15 over 3. Oh, 15 isn't to the 1/2 power. That's what I'm messing up. Sorry. 15 is to the -2nd power. This is to the 1/2 power, and then the whole thing is to the -2nd power. Okay, that's going to be a lot easier. That's good. So let's get rid of this. Sorry. So we have 15 times 1/9. The square root of 1/9 is 1/3. So it's 15 times 1/3, which that's a 5. And now we have the log, base 10, of course, no base, that's what I was looking for, 5 to the -2nd. So this is going to push this 5 into the denominator and square it. So we have the log of 1 over 25. So this next one, again, I'm just going to go through and set it up and then try to figure out how to fix it. So we have log, the 72 is on the top. All of this is to the 1/3 power, but this is 4 squared times 32, and then all of this is to the 1/3 power. You can absolutely put that into your calculator. Don't try to do that without it. So this turns into an 8 on the bottom, and 72 divided by 8 is the log of 9. Here, of course, we don't have the ability to use the calculator because of the letters. So let's see what happens here. So we have log base 3. A is to the 3/2, that goes on top. And the bottom, we have 16a squared. And then that, of course, is to the 1/4 power. Yikes. So we have a to the 3/2 over 16 to the 1/4. That's a 2. Put that in the calculator. And then you multiply your power to a power. 2 times 1/4 is 1/2. And now we have to subtract 3/2 minus 1/2 because we have to subtract the powers when we divide. That's 2 over 2, so that's a 1. So now we have just a to the 1st power. Log base 3, a's on the top, but that's to the 1st power, that's what we figured out, and there's a 2 on the bottom. Now we're going to go the other way. We're going to expand these out. So these are going to get kind of, the idea is that they get kind of big and messy. That's the whole point. So we have log base 7 of x plus the log base 7 of y to the 3rd. And of course this goes out in front. Log base 7 of x plus 3 log base 7 of y. Natural log doesn't change, it's just easier to write. Natural log of m to the 3rd minus the natural log of n to the 7th. So 3 natural log of m minus 7 natural log of n. This one, I'm going to rewrite this a little bit. This is a to the 3rd log, of course, sorry, a to the 3rd b to the 1/2. Remember, square root is the 1/2 power. So this is going to bring this 1/2 down, and we're going to have the log of a to the 3rd plus the log of b. So this comes here, and then we have to distribute. So I have a 1/2, and now I have a 3 out in front of this. So I have 3/2 log of a plus 1/2 log of b. This is going to be, the 4 comes down, and we have the log base 4 of c squared minus the log base 4 of d. So let's see what happens here. So we have the 4 times, and then this is a 2. Sorry, I forgot to bring my 2 down. So 4 is here, and then the 2 comes out. So 2 log base 4 of c minus log base 4 of d, and then distribute the 4. 8 log base 4 of c minus 4 log base 4 of d. All right, these are the crazy ones. If you can do these, you can do any of them. Lots of P's and Q's. I don't know why they use P's and Q's, but so 2, okay, this is helpful. 2 comes down out in front. And then we're going to have the natural log of 5p to the third plus the natural log of q to the fourth. Right? I mean, that's kind of how we're going to get started here. So let's spread this out. We have 2. We're multiplying, so we're going to add natural log of 5 plus, bring the 3 down, 3 natural log of p plus 4 natural log of q. Oh, that wasn't so bad. Distribute the 2. 2 natural log of 5 plus 3 natural log of p. Oops, I'm distributing, but I forgot what I was doing. This is 6. And then plus 8 natural log of q. Last one, but you didn't think we'd ever get here. Let's rewrite this a little bit. This is x to the 1/3 on top of, ooh, we gotta factor this. Sneaky. Yeah, that has to be factored. Sorry. Log base 2 of x to the 1/3 minus all of this. Log base 2 of x, and we're multiplying, so we can go ahead and put log plus log base 2 of x plus 1. What else do we have to do? Oh, not much. All we have to do is bring this 1/3 down. Okay. 1/3 log base 2 of x minus, I'm just going to, you can distribute this minus sign. Let's do it. Log base 2 of x minus log base 2 of x plus 1. So let's talk about what this looks like. Anytime, every time you see a minus sign, all that means is that goes into the bottom. It does not mean you make a new fraction. So a negative sign means shove it to the bottom. That's the first time we saw 2 negative signs, so I wanted to point that out.